Today is 4.2, day 2. So remember, an exponential function is of the type y equals a times b to the x. So what we're going to do in number 1 is we're going to do something called solving the equation by getting a common base. So remember, b is the base. In y equals a times b to the x, b is the base. So in letter A, if I have 8 to the x equals 4, you need to think a moment about how could I rewrite 8 and how could I rewrite the 4 so that they had the same base. Well, 8 is 2 cubed and 4 is 2 squared. Now we're going to see a nice connection to what we did the day before. On the left side, I'm going to use the power to a power, so that's going to become 2 to the 3x equals 2 to the second. Once you have the same base, the exponents are equal. I'm not canceling the bases. I don't want you to misunderstand. I'm not canceling the bases, but once I get the bases equal, then I know that the exponents must be equal. And then you would divide both sides by 3, and x is 2/3. So some of this is going to rely on some number sense, understanding relationships of numbers. So if I look at 27, okay, that's not 2 to a power. What base might that be? Well, 27 is 3 cubed. 81 is 3 to the 4th. But what I want you to notice is because it's 1 over 81, that's actually going to be 3 to the negative 4 power. So think about our negative exponent property from the day before. Again, on the left side, that's a power to a power. And I'm going to say the exponents are equal. So x is negative 4/3. All right, in letter C, I'm going to change 49 to 7 squared, and 9 is 3 squared. Now, do you notice I have this negative exponent? So do you remember you can flip the fraction and make it a positive power? Okay, if you have a fraction to a negative exponent, you can flip it. Now, I'm going to do some fancy math, and I'm going to use this property that if you have a to the m, excuse me, let me rewrite that. If I had a over b to the m equals a to the m over b to the m, I'm just going to go from the right side to the left side. So 7 squared over 3 squared had to have been 7 over 3, the quantity squared. And that's all to the x power. Then on the left side, and I apologize, this should not always be on the left side. It can be on the right side. So then I can multiply the power times the power. So now we're going to find out if you really do know your exponent properties. So now the bases are the same. I can set 2x equals 3/2. Now you have two options here. You can divide both sides by 2, but then you're going to have a fraction divided by 2, which is kind of tricky to deal with. So instead of dividing by 2, you can actually multiply by 1/2. So I get x equals 3/4. So what we've done is we have been solving equations by getting a common base. In letter D, I need to get the exponential term alone. So 6 to the x plus 2 is the exponential term. So to get that alone, I'm going to add 4 to both sides. And something I want to mention is it's not horrible if you can mentally be checking what goes in, but sometimes these are going to be really difficult to do. So I do want you to go through the process instead of doing a guess and check. Okay, there's nothing wrong with guess and check, but because of where we're headed and that this is a skill set I want you to develop to do harder problems, I want you to go through the process. All right, so finally I got one that's going to work to the right side. So 36 is 6 squared. Now I have the bases are 6, so I can set the exponents equal. Oh, this is interesting. X equals 0, so that's okay. All right, letter E. So I'm trying to end up getting 7 to the x minus 1 power alone. So my first step is to subtract 3. So that's 98. Now I'm still trying to get 7 to the x minus 1 power alone. So what do you think we might do here? If you said divide by 2, you're right. Then 49 is 7 squared. So now I can set the exponents equal, and then this is a lovely, simple equation. All right, so these 5 were exponential equations because the variable was in the exponent. So let me say this again. These 5 were exponential equations because the variable is in the exponent. So that's what exponential equations are. The variable is the exponent. All right, well, we have something called a power function. And a power function is that I have maybe a coefficient, but the variable is the base, okay? And the exponent is a constant. It's a number, a real number. All right, so in number 2, we're going to learn how to solve power functions. So if I have x to the 4th equals 1 over 16. So something I need to mention is when you have an even power, be careful. You need a plus or minus root when it's an even power. So if you remember when we had x squared and we were solving for x, we had to do plus or minus the square root. So here, I'm going to do plus or minus, and I'm just going to do the 4th root. So you want to think about what times itself 4 times is 1 over 16. Well, hopefully it doesn't take too long to figure out that 1/2 times 1/2 times 1/2 times 1/2 is 1 over 16. But that was a 4th root. So in letter B, there's no parenthesis around the 3 with the x. So it's 3 times. This really means 3 times x to the 3/2. So I'm going to divide both sides by 3. And I would get 64. Now, this power, the power is a 3rd on the top, okay, the 3rd power. That little 2 doesn't impact with a plus or minus. So it's that the power is even. So this is a 3rd, and then it's a 3/2. So watch what we're going to do now. Remember our power to a power property? You can actually raise both sides to the reciprocal power because, do you remember the exponent property, a power to a power? And we use that many times up here in letter A and B and C. Like we use this, that's 1. 3/2 times 2/3. That's why you want to do this. Then for now, you can use your calculator. You're going to type in 64 and then use the caret button and then do 2/3 power. And it should give you 16. We'll learn in the next section how to actually do these precisely. For now, we're going to rely on the calculator. All right, in this one, I want to take and raise both sides to the reciprocal power, which is -1/3. So this is going to be x to the 1. And if you punch this in your calculator, it's going to give you 0.33333, which is 1/3, because I did say no decimals. All right, letter D. I need to isolate the x to the 1/4 power. I'm going to divide by the 2, and I need to do the reciprocal power, which is 4. So this is x equals, and if you use your calculator, that's 256. All right, so the 1/4 power, it does not have, so when I talk about having, say, x to the m over n, I'm talking about the m is even, not the n, okay, in the fraction. So in number 3, letter A, this is where I've got to be careful. When I take x to the 6th to the 1/6, so this really could be a plus or minus here. Go ahead and when you type this one in, so this one does say, now round to the nearest hundredth. That's what 0.01 means. So you're going to get plus or minus 3.16. All right, on this one, I'm going to need to multiply both sides by -2. Because I need to first get rid of the -1/2. So when I do that, I get x to the 4/5 equals 864. Do we need the plus or minus? The answer is yes, because this top number is even. So what I'm going to do is I'm going to raise both sides to the reciprocal power. But then I'm going to need x equals plus or minus. So pause the video and raise 864 to the 5/4 power. What do you get? I got 4,684.27. All right, so that finishes the notes pretty quick.